That skill presents rules of indices. When a number is multiplied by itself a certain number of times, we can write it in exponent form. So 3 times 3 is equal to 3 raised to the second power, also called 3 square. And 2 times 2 times 2 is equal to 2 raised to the third power, also called 2 cubed. The number that is multiplied with itself is called the base. So this is the base, 2 is the base. On this one, 3 is the base. And the number of times it multiplies with itself is called the exponent. So because there are 2 3's in this multiplication sentence, we have 2 on the top and it's called the exponent, also known as the power. On the second one, because 2 has been multiplied with itself 3 times, you see this 3 here. This indicates that the number 2, which is the base, has been multiplied with itself 3 times. So this is the exponent of the power. And when the power is 2, we call it a square. When the power is 3, we call it a cube. These are 2 special names you want to remember. You could also say raised to the second power, raised to the third power, raised to the fourth power, and so on. There are a few laws of exponents you want to know about. The laws of exponents, also called the rules of indices. And the first one tells us that if there is a base x and that's raised to the power of a, and that has been multiplied, so x raised to the a has been multiplied with x raised to the b, where a and b may be the same or different numbers. As long as the base is the same, x and x, you could combine them and rewrite that as x raised to the a plus b. Now why this works is pretty easy to understand. This one is a multiplication sentence in which x has been multiplied a number of times. So you have ax's, and on this one you have bx's. So if you multiply this with this, you have a plus b number of x's in all, which is written as x raised to the a plus b. In the same way, if x raised to the a is divided with x raised to the b, you have x raised to the a minus b. Remember, a fraction bar is nothing but a division. So essentially, we are dividing a number of x's with b number of x's, and some of the x's cross off from the numerator and the denominator, and in the end you are left with a minus b number of x's. And then if you have an exponent x raised to the a, and that itself has been raised to another exponent b, this is going to be equal to the same base x raised to the a multiplied with b. So the exponents are multiplied when an exponent has been raised to another exponent. Once again, it's pretty obvious. If you just open this up, you'll realize that this is essentially a number of x's multiplied with another a number of x's multiplied with another a number of x's, and how many times you do that is determined by this number b here. So if b is 3, you do x raised to the a times x raised to the a times x raised to the a. So you have 3 a's in the end, and reason why we multiply b with a. And then we have a couple of important derivations. If you look at this quotient formula here and set a is equal to b, which means the same number of x's on the top as on the bottom, and we know that when a number is divided with itself is always equal to 1, provided that number is not 0. So you cannot have 0 over 0, that's undefined. As long as x is not equal to 0, and if you set a is equal to b, this is going to be equal to 1. Now, if you set a is equal to b on this side, we have x raised to the a minus a, which is x raised to the 0. So here's an important derivation. X raised to the 0 is always going to be equal to 1 as long as x is not equal to 0. And in the same way now, if you set b to be a number that's larger than a, let's say a is 0 and b is, let's just keep it as b. So we have 1 over x raised to the b. The numerator becomes 1 the moment a is set to 0 because we just learned that x raised to the 0 is 1. So we have x raised to the a over x raised to the b. Set this equal to 0. So we have x raised to the 0 over x raised to the b. And we just learned that this is equal to 1. So 1 over x raised to the b is what we have. And that is equal to, if you apply the formula, this becomes x raised to the 0 minus b, which is x raised to the negative b. And that leads us to conclude that when we have a negative exponent, that's the same as the reciprocal of the exponent without the negative sign. And it also helps to remember a couple of things. If you have a times b, a product raised to a certain exponent, m, it's the same as the product of the two exponents. So this is going to be equal to a raised to the m times b raised to the m. And the same thing goes for quotient division. So if you have a over b or a divided by b raised to the m, this is equal to a raised to the m divided by or over b raised to the m. Let's look at a few problems. Let's say we want to simplify 2x, all of that raised to the third power, multiplied with 3y square raised to the second power. So this is going to be equal to 2 raised to the third times x raised to the third times 3 squared times y squared raised to the second. This is equal to 2 raised to the third is 2 times 2 times 2, which is 8, times x cubed or x raised to the third times, this is 9, 3 raised to the second, 3 times 3, times y raised to the second and that raised to the second. So that becomes y raised to the 2 times 2, which is y raised to the fourth. We should multiply the constants together. So 8 times 9 is 72. And the final answer is 72 times x raised to the third, y raised to the fourth. Let's have another one. 3p raised to the third or 3p cubed and that raised to the second power, all of that, divided with 2p square of all of that means raised to the second power times p square raised to the third power or p square cubed. So this is going to be equal to, apply this exponent of this index on the 3, so this becomes 3 square times this one on this one, so this becomes p raised to the third raised to the second power over this on this, so that becomes 2 square times this on this, p square times. Let's simplify this in the next step along with this one. So I'm just going to keep that as p square raised to the third power. So this is going to be equal to 3 square is 9, p raised to the 3 times 2, which is 6. So we have p to the 6th over 2 square is 4, p square times p raised to the 2 times 3, which is 6 again. And that's equal to 9 over 4, p raised to the, we have a 6 and another 6 on the top, so it becomes a 6 plus 6, and there's a 2 on the bottom, and that becomes a minus 2. So this is 9/4 p raised to the 12 minus 2, which is 10.